Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. Now we'll connect the first component with microcontroller, and this component is a green LED of 5 mm. Here we can find D13, and this D13 is green LED of 5 mm which is connected with port RC3 of microcontroller, which is pin number 18 of microcontroller. Here we can find a label test LED, and the same label is on pin number 18, that is RC3 of microcontroller. So the cathode of LED is connected to pin number 18 of microcontroller, and anode of LED is connected with 5 volt with 390 ohm resistor. First we will develop the circuit of LED, and we will write our first program to test the LED. We will write a program in MikroC to toggle the status of LED, that is on and off, and the duration of LED blinking will be 0.5 second, that is 0.5 second on and 0.5 second off. Here we can find the anode of LED is connected with 5 volt with 390 ohm resistor, and cathode of LED is connected with port RC3 of microcontroller. It means that if the port of microcontroller will go low, the LED will be on. So we can say that this LED is active low. So let's start developing our first circuit. Here we have a green LED and a 390 ohm resistor, and I'll connect this green LED with pin number 18 of microcontroller. I'll connect the cathode of this LED with port RC0 of microcontroller, and anode will be connected to 5 volt through 390 ohm resistor. Here we can find a short and a long pin of LED. This short pin is cathode, and we can also find a cut on cathode side. A flat cut shows that this side is cathode. So I'll connect the cathode side with pin number 18 of microcontroller. Here I have soldered the LED in Vero board. Now I'll connect a resistor of 390 ohm with anode of this LED, and I'll connect the second end of resistor with 5 volt. Here I have soldered 390 ohm resistor with this LED. Now I'll connect the second end with 5 volt. Here we have 5 volt on right hand side of this resistor, and this resistor is part of power on reset circuit. So I'll connect the 5 volt to the LED circuit from this point. Here we have completed the 5 volt connection to the LED, and we have connected the cathode of LED with pin number 18 of microcontroller. Now we'll check the continuity of this circuit. I will check the continuity of this 390 ohm resistor with 5 volt. Okay, this resistor is connected with 5 volt. Now I'll check the continuity of this resistor with anode of LED. Here we can check the anode of LED is connected with the resistor. Now I'll check the continuity of cathode with pin number 18 of microcontroller. Okay, cathode of LED is connected with pin number 18 of microcontroller. The first component interface of our prototype is completed. Now we'll write a program for this interface, and we'll write a program to blink this LED with 0.5 second. It means that 0.5 second on and 0.5 second off. We'll write our first program in MikroC. Here you can find the website of Microelectronica. You can find MikroC for ARM microcontroller, PIC32 microcontroller, MikroC Pro for PIC, MikroC Pro for DS-PIC and PIC24, MikroC Pro for 8051, MikroC Pro for FT90X. You can download the demo version of MikroC for PIC microcontroller from this site. Here you can find download. You can purchase MikroC compiler from this site, and you can find the price is $249, but you can download the demo version from this site also. Okay, download is completed. Here you can find MikroC PIC setup version 7.2. Go to the folder, unzip the file. Okay. Now you can install the demo version of MikroC Pro for PIC microcontroller 2018 build 7.2. Now I'll start MikroC for PIC microcontroller. Here we can find a start page for MikroC for PIC microcontroller. Now we'll go for the project. We'll go for close project. Now we'll go for new project. In new project wizard, we will select a standard project option. Okay, next. Now we'll assign the name to our project. That is LED Blink. Now we will assign the path to our project. Browse. Make a new folder. MikroC projects. Select the folder. Okay. Here we have our project folder, MikroC projects. Now we'll select the device, and here we can find the microcontroller which we will use in our project, that is PIC16F877A microcontroller. Select the microcontroller. Now we'll select the device clock frequency, that is 10 MHz in our case. It is better to save each project in a separate folder, so we'll make a separate project folder for our first project, that is LED Blink. We'll go to Browse, we will select MikroC projects. We'll make a new folder and we'll assign the name to new project, that is LED Blink. Okay. And next, select existing file you want to add to project. No, we don't have any existing file to add our project, so we'll go to Finish. Okay, here we can find the main routine for our project, that is LED Blink project, and here we can find two curly brackets, that is start of our main routine and end of our main routine. Here we can find our microcontroller, that is PIC16F877A, and the clock frequency is 10 MHz. Now we'll start writing our program. First I'll place the cursor on wide main. Enter. Here I have developed a space for my assignments and comments. First I'll write a comment for my program, and I'll start the comment from /. Now I can write comments for my program. My first LED program, my first LED program, written by Professor Electronics. Dated 30/07/2018. Now I'll add port assignments to my program. Now we will assign the name to the port on which we have connected the LED, and to assign the name we will write hash define test LED port C.F3, because we have connected the LED on port C3, so we can assign the name to port C3, that is test LED. Okay. In future we can define more ports in this port assignment section. Now we will initialize port RC3 as output, and I'll initialize this port in main routine. First I'll assign comments to main routine. Main program. Now I'll initialize port RC3 in main program. For this I'll initialize the tri-state as output, and I'll write RISC C.F3 equals to 0 and semicolon. It means that the tri-state for port RC3 is configured as output. Now we'll start the while loop from do, start the curly bracket and end the while loop here. While 1 and semicolon. We'll write our program between do and while. As we have assigned the name, that is test LED, to port RC3, so we'll use this name, that is test LED. Control C and Control V equals to 0. As we know that this LED is active low. If the port will be 0, then LED will be on. Now we'll call a delay of 0.5 second. For this I'll write a command, that is delay underscore millisecond and 500. It means that wait for 500 millisecond, that is 0.5 second. Now enter. Again copy test LED equals to 0, Control C and Control V, and make it 1. In this case LED will be off because LED is active low. Now we'll copy this delay again, Control C and Control V, and that's it. Our program is completed. We have written our first program of LED blinking. Now we'll compile our program and we'll download the hex file to the microcontroller and we'll observe the result of our program. So now to compile the program, I'll go to the icon here, Build. Here we can find no error is here. Here we can see the program has used the RAM bytes 2, that is 1%, and free RAM is 350 bytes, that is 99%. And we can see the ROM utilized by the program is 36 words, that is 1% of the total memory, and free ROM program words are 8156, that is 99% of the total memory. Here we can find project link successfully, LED blink, and project is compiled to hex. Now we'll download the program to the microcontroller and we'll observe the result of our program. Picket 3 programmer is ready to program the microcontroller. Now insert the programmer into prototype. Now I'll run Picket 3 programmer software. Here we can see PIC16F877A microcontroller is detected in board. Now we'll select the hex file and download to the microcontroller. We'll go for File, Import Hex. In MikroC projects, we have another folder that is LED Blink project. And here we have our hex file. Select the hex file, open. Here we can see hex file successfully imported. Now we'll download the hex file to the microcontroller, right? Here we can see programming successful. Now we'll energize our circuit. Okay, we have downloaded our program successfully in microcontroller and it's working properly as we have written this program in our MikroC compiler. The LED is blinking with 0.5 second delay, that is 0.5 second on and 0.5 second off. Now we'll interface some more components with microcontroller, that is 8 LEDs, multiplex 7 segment displays, buzzer, LCD display, and analog interface circuits.